Black holes. The most mysterious objects in the cosmos.
The universe is bizarre, but if you were to make a list and say, what's at the top? Black holes.
Black holes excite the imagination. The fact that we see them at all is extraordinary.
Their immense gravity makes black holes the most destructive objects in the universe.
They can rip apart a star in seconds.
But they have another side.
These are not horrible, dangerous things. These are wonderful, mysterious parts of the universe.
To unlock the secrets of black holes, we will strip them apart. We will reveal how black holes are born, how they wage the most violent battles in the cosmos, and how one day humans could travel through them. Black holes. The most powerful objects in the universe, capable of destroying entire worlds. For decades, they have terrified us with their mystery and darkness.
The reason why we call a black hole black is because light cannot be emitted from inside the black hole. It's a one-way street. It can go in, but it can't come out.
If you're close to a black hole, they're terrifying. There's huge amounts of matter that can fall into them. This matter gets very hot, it gets torn apart. It falls into this basically infinitely deep hole in the universe itself.
But there's more to black holes than chaos and destruction.
The more we learn about black holes, the more we understand they have a real purpose in our universe. They're sort of cosmic organizers. They bring things together.
Could new discoveries change how we see black holes?
I definitely think it's time for an image makeover for black holes.
Black holes are more than darkness. Stripping away a donut-shaped shroud of cold dust on the outside, reveals a huge disk of cosmic debris, spinning at millions of miles an hour. This is where the black hole feasts. Gas, dust, shattered stars, and planets all descend into the gaping mouth of the black hole. It's called the Event Horizon. It's a perfectly dark sphere from which no light can escape. Inside, the laws of the cosmos break down.
Black holes are a place where some of the rules we think about in the universe don't apply as well as they do out here. When you're falling into a black hole, you move faster and faster and faster, and you finally reach the speed of light as you pass into the black hole itself. But then what happens inside of that? We don't know.
We are confronting something that the human brain doesn't understand, where space and time itself break down, don't behave the way we think of them. That's going to push us to evolve, to understand the very nature of reality better.
30 years ago, black holes were purely theoretical. A mathematical prediction made by Einstein. But now we know they're very real. This is our galaxy, the Milky Way. Stripping away its stars, planets, rocks, and dust reveals a dark secret. Lurking in the shadows is a massive black hole, Sagittarius A star. 4 million times the mass of our sun and just 26,000 light years from Earth. Studying this titan offers us a chance to understand how black holes truly work. On top of Hawaii's tallest mountain, Mauna Kea, scientists at the Keck Observatory do just that. Astronomer James Light studies Sagittarius A star.
It's so unique to have a black hole that massive, that close to us, because all the other ones that are that massive are so far away in other galaxies.
Getting to his office requires a 14,000-foot climb along a steep and winding dirt road.
I've loved telescopes for a long time, and these are the biggest and the best. So if you want to get the faintest objects in the universe, if you want to look at the finest detail, you have to come to Keck. It takes your breath away.
Today, James prepares Keck's 300-ton telescope to monitor Sagittarius A star.
The telescope's going to come very close right behind me. You know, it takes a dedicated crew of 20 guys to get this thing running every night of the year. It's a very complex machine.
The constant movement of the Earth's atmosphere bends light and makes stars twinkle. This distortion stops scientists from getting a clear view of the Milky Way. But the team at Keck has cracked this problem. As night falls, James shoots a bright laser 50 miles up into the atmosphere.
We take pictures of the return from that laser. It gets fuzzed up by the atmosphere just the same way as the natural star does.
By altering the telescope's mirrors, James brings this beam of light into focus. This allows him to calibrate the telescope and obtain the sharpest images ever seen of objects in the Milky Way.
It's a revolution in astronomy. This is a technology that was dreamed about for years. It's a bit of a game changer. And we now can see things that we never could see before.
James and his team are making startling discoveries that are changing our understanding of how black holes work. They have detected a mysterious object close to Sagittarius A star. It's called G2, a cloud of interstellar gas which may contain a star. Its future is bleak. Scientists believe the black hole will slingshot part of the cloud into space, and then gorge on the remains, growing even more massive and powerful.
G2 happens to be one of the closest objects to the black hole. Anytime you get that close to that extreme of environment, you'll get to see new physics, you get to see fantastic things.
Soon, the team will see a black hole feeding for the very first time. Sagittarius A star is 4 million times more massive than the Sun. But 300 million light years away, there's a black hole 5,000 times larger. Deep inside a galaxy called NGC 4889 is the biggest black hole ever found. It's so powerful, it can shred supergiant stars that come too close. What gives black holes the power to destroy entire worlds? "26,000 light years from Earth, a black hole called Sagittarius A star is about to shred and swallow a gas cloud. Why do black holes have such massive power? And how do they form?
The way that a black hole can form is by the death of a massive star.
You need a star that has at least 8, 10, 20 times the mass of the sun. And they can actually produce millions of times the energy that the sun produces, putting out in just a few seconds as much energy as the sun does in an entire year.
These are the hypergiants, the biggest stars in the universe. As they run out of fuel, they begin to die. When they can no longer hold up their own weight, they collapse, releasing a massive burst of energy. A supernova so powerful that only the Big Bang was bigger. The remaining core keeps collapsing and squeezes into a single point in space smaller than an atom. A black hole is born. This observatory in Southern California is the workplace of one of the few people on Earth to witness this process. Doug Leonard hunts for black holes.
In 2005, an alert went out that a new supernova had appeared in the galaxy NGC 266. My reaction was to try to get a very close-up, detailed picture of the supernova right around it. And that's what we did with this picture.
Doug scoured the archives of the Hubble Space Telescope and discovered that before this star collapsed, it was a hypergiant.
And this made me very excited because it's just the kind of star that we think, after it dies, leaves behind a black hole.
If Doug looks at this point in space now, it is no longer bright.
And according to our best theories and calculations, right there is a brand new black hole. That looks good. Beautiful night, no clouds.
Despite 9 years of searching, Doug hasn't found another supernova big enough to form a black hole.
All right, we're ready to roll. Let's go.
Now, he studies the biggest black holes in the universe. Those like Sagittarius A star, with millions of times the mass of our sun. The supermassive black holes. As supermassive black holes grow, their increasing gravity pulls more and more objects into a gigantic revolving disk. Inside, friction builds up, and the disk starts to glow. The faster the disk spins, the greater the friction, and the brighter it becomes. Doug's team can measure the intensity of this glow and then calculate the power and size of a black hole.
Very simply, the faster things orbit the black hole, the more massive the black hole has to be, because more gravity has to be tugging harder on the object to make it orbit more quickly.
Using this technique, Doug is finding black holes tens of millions of times the size of the sun.
Hopefully, we can push these kinds of studies to greater and greater distances and better understand the dynamics of all supermassive black holes.
Black holes are the dark horses of the cosmos, but supermassive black holes are linked with far, far brighter lights.
Back in the 1960s, when people were pointing radio telescopes and X-ray telescopes in the sky, they were detecting really powerful sources of energy.
Scientists called them quasars. They weren't explosions, just very intense lights that outshined entire galaxies.
When we first realized how bright quasars really were, we couldn't account for the amount of energy. What could possibly be creating that much energy?
So imagine you've got a source of energy which you know is very far away and is very bright, which means it's incredibly powerful. It must be fantastically luminous. Something must be generating that energy. What could possibly be an engine big enough to power something so big you can see it clear across the universe?
The answer is a supermassive black hole. If too much matter squeezes into its mouth, collisions become so violent, they release gigantic amounts of energy. Immense, luminous jets spray out hundreds of thousands of light years into space. This is a quasar, the brightest light in the cosmos.
Black holes are such voracious eaters that they eat like the Cookie Monster. Most of what they eat does not end up inside. A lot of it gets spit out. And it gets heated to these immense temperatures, and that matter glows very, very brightly.
As material falls down this giant gravitational well into a black hole, it's almost like it's in a particle accelerator. It accelerates faster and faster, gets hotter and brighter, and all of a sudden you can see these things from clear across the universe.
Some quasars are epic. 3 billion light years from Earth, astronomers have discovered a quasar called 3C273, the brightest known object in the universe. At its heart is a supermassive black hole, 1 billion times heavier than the Sun. It consumes 600 times the mass of the Earth every minute and spits out 100 times more energy than all 300 billion stars in the Milky Way combined. Astronomers are now detecting these bright lights all over the universe.
As we scan the cosmos and we look ever deeper, we see more and more quasars. And there's only one way to form a quasar, and that's a supermassive black hole. And we're finding them by the millions. So these things are everywhere.
Once we thought black holes were purely theoretical. Now we know that billions exist across space. Why are there so many black holes in the universe? Black holes. Once scientists thought they were extremely rare, but now they're discovering billions of them across the cosmos. Why are there so many?
There's this idea, and it's strange, that every major galaxy in the universe has a supermassive black hole in its center.
And then people started to look over their shoulders and wonder, could there be one at the heart of our own Milky Way galaxy?
At 4 million times the mass of the Sun, Sagittarius A star is a supermassive black hole. Could this be the center of the Milky Way? In Los Angeles, a team of scientists tackles this question. Astronomer Andrea Ghez pins down the role of Sagittarius A star.
Black holes themselves are very dark objects. You can't see them directly. What is available to us is the influence of its gravitational field. So we're studying the stars that are the closest to the black hole and watching how these stars move.
After 2 decades, the team is discovering something remarkable about Sagittarius A star.
All these stars that we measure are all going around the black hole. They're just going around on different timescales.
The immense gravity of Sagittarius A star holds all these stars in their orbits. Stripping back the dust and gas in the Milky Way reveals these stars are not alone. Every single object in the Milky Way orbits around a single point in space. The supermassive black hole, Sagittarius A star. The center and master of our galaxy. It is 26,000 light years away from Earth, but even at this distance, we cannot escape the grasp of this supermassive black hole.
The Earth is also moving around the center of the galaxy, and we are traveling at 500,000 miles per hour.
Sagittarius A star is not the only black hole that controls a galaxy. As scientists scan more and more galaxies across the universe, they're discovering a supermassive black hole at the center of every single one. Far from being rare, supermassive black holes are everywhere.
There's millions and hundreds of millions of galaxies in the observable universe, and there's a supermassive black hole at the center of each one? That is insane.
But it gets better. Supermassive black holes don't just anchor galaxies, they may also build them. A black hole's intense gravity pulls passing stars into orbit. Their combined mass attracts more and more stars, and slowly forms the galaxies we see today. With a supermassive black hole at their centers that's both master and maker.
This is forcing us to reevaluate the way we thought galaxies formed in the first place, and it also is making us reevaluate the role that black holes have in the universe.
So you need black holes to get galaxies. You need galaxies to form stars. You need stars to form planetary systems. You need planets to host beings like us. And so the black hole is in fact an anchor for our very existence.
Black holes are shaping our universe, but could they also threaten the future of our galaxy? Our universe may seem like a serene and peaceful place, but looks are deceptive.
Space looks really tranquil when we look at it from Earth. It looks beautiful and peaceful, but really there's a lot of violence going on out there.
Stars are exploding, galaxies are colliding. So I see myself surrounded by a universe of drama.
Our galaxy, the Milky Way, is heading for one of the most dramatic events in the cosmos. In 4 billion years, it will smash into our nearest neighbor, the Andromeda Galaxy. At 250,000 miles per hour. The two galaxies will start to merge into a new supergalaxy called Milkdromeda, and their black holes are predicted to collide. Across the universe, black hole collisions are common. But their dark nature makes it impossible to see what happens during these impacts. Jameson Rollins hunts for these collisions. He doesn't look at black holes, he listens to them. These are his ears. LIGO, a $1 billion network of tunnels and lasers.
We're really opening up a new window on the universe. We're starting to listen to the universe in a way that we've never listened to it before.
The immense gravity of a black hole causes ripples in the fabric of space. Once online, LIGO will listen out for these gravitational waves.
LIGO is an L-shaped instrument where the lengths of the arms of the L are 2.5 miles long. And We essentially shoot laser beams down the arm, and we can very, very, very precisely measure the length of the space in the arm. When a gravitational wave comes by, it causes that space to very slightly shrink and expand, and we can measure that.
This movement is tiny, less than the width of an atom. But once the team completes LIGO in a few months, they will be able to hear the sound of black holes colliding.
When they're orbiting around each other at a sort of constant rate, you hear a single tone, and but as they emit the gravitational waves, they get closer together, they move faster, and the signal goes up in pitch and in amplitude, so it makes a chirp, and until they eventually collide and explode.
The sounds they will detect are just faint echoes of the real event. The violence of a black hole collision is inconceivable. Deep inside a bean-shaped cloud of hot, dense stellar debris, the black holes fight for supremacy. They accelerate as they get closer and closer. Finally, they smash into each other, sending a massive shockwave tearing through the cosmos.
It's hard to say what I'm going to be feeling when the first signals come in. I mean, I've been working on this my entire career, and it will be incredibly exciting. I'm sure we'll have a big party.
But if LIGO confirms our theories on black hole collisions, the future looks grim for our galaxy. When the black holes at the centers of the Milky Way and Andromeda merge, they will create a monster. A black hole powerful enough to consume millions of stars. The survivors will face brutal reorganization under the new master. The black hole's extreme gravitational pull will throw planets into new orbits and cause stars to collide. Chaos will reign. A single black hole will control the fate of trillions of stars and planets.
You might think the sun is powerful. You might think even a big, massive star is powerful. But the most powerful of all is a black hole.
Scientists have discovered how black holes form galaxies and dictate their futures. But one big mystery remains. What happens deep inside a black hole? Black holes were once just a theory, a prediction made by Einstein. Now we know they control galaxies and power the brightest lights in the cosmos. But they still hide a secret, something that even Einstein couldn't see. What happens if we venture inside the event horizon, the boundary surrounding a black hole, from which light cannot escape?
I think that would be a pretty cool mission. Just the idea of exploring something like that, I think that would be quite an opportunity for the astronauts of the future.
We actually have a pretty good understanding of what happens outside of a black hole, but we don't know what happens at that final split second, that shaved slice of time, when you pass that point of no return and hit the event horizon.
In Scotland, a remarkable experiment intends to reveal what's beyond the event horizon. It is the brainchild of Daniele Faccio.
It's basically unexplored territory, and that's where we can really push the boundaries of our knowledge.
Faccio doesn't use a telescope. And he's not an astronaut. Instead, he makes black holes in his lab. His key ingredient is light.
We have extremely powerful lasers which force the light to start to behave and start to flow as if it were a fluid.
Near a black hole, space also flows like a fluid. It moves towards the event horizon like a river heading downstream.
Imagine a flowing body of water and you're trying to swim against this flow. What you'll feel is the river will try to drag you along with it. And this is exactly what a gravitational field is doing outside a black hole.
Faccio forces light into a tight whirlpool, just like matter descending into a real black hole. And he is making scientific breakthroughs. When he fires a wave of light towards one of his black holes, something strange happens.
You can see these waves, which aren't moving, they're essentially frozen at the boundary of the horizon that we've generated.
These frozen waves confirm a prediction of Einstein's most famous theory, relativity. Einstein thought that near a black hole, gravity would start stretching time. A second would expand to years, or even centuries. Seen from a distance, objects would seem frozen in time. Exactly what Faccio sees with his experimental black holes. He is confident the same thing happens in space.
If you were to observe a spaceship or someone falling into a black hole from very far away, you would actually never see that person pass through the event horizon. You would see them approach the event horizon, time as seen from us would slow down, and we'd see them slow down and essentially remain frozen on the event horizon forever.
But the astronauts inside the spaceship wouldn't notice time being stretched. They'd experience the same gravity changes as their surroundings. For them, time passes normally, while gravity drags them to the event horizon. Even Einstein didn't know what happens next. But Faccio thinks his experiment will one day solve this scientific mystery.
It's as if this was a slice directly through the sphere of a real black hole.
This allows him to see beyond the event horizon and probe the inner workings of a black hole for the first time.
This is really exciting. I think this is where all the new physics is hiding.
With this new scientific knowledge, we could finally explain what happens inside a black hole. For now, what lies beyond the event horizon remains a mystery. Some think there's a fiery inferno.
It could be like a giant firewall that everything gets sucked in at once, that all smashes together and kind of vaporizes in a big explosion.
Others predict something called a singularity.
It's where all space and time converge into a single point. And time, too. Time comes to a stop, which is crazy to think about.
While some think the black hole spaghettifies everything that enters.
If you go into a black hole feet first, then the force of gravity at your feet will be much stronger than the force of gravity at your head. And you get stretched out into this long, thin strip till eventually your molecules break apart and your atoms break apart, and you basically go into the black hole as a thin strip of vapor.
Black holes defy understanding. But theoretically, there could be something even stranger out there. A black hole reversed. A white hole. Instead of sucking matter in, it spits it out in a frantic volcano of energy. White holes could open up new horizons for humanity.
One of the amazing properties of black holes and white holes is that sometimes they can link to form a wormhole. And when that happens, you can enter the black hole at one place in the universe and exit the white hole at a very different place. So in essence, the black hole sucks you in and the white hole spits you out.
If these bridges exist, they offer a tantalizing opportunity. Could we travel through these wormholes? And what would this journey be like? Once, they were a science fiction writer's wildest dream. But now, scientists believe wormholes are very real, and they could revolutionize space exploration.
The beauty of a wormhole is that it allows us to travel vast distances in almost no time at all. Imagine if I wanted to travel to the Milky Way galaxy, that in this example is at this end of the paper, to the Andromeda galaxy at this end of the paper. That's 2 million light years. Even if I traveled at the speed of light, it would take me 2 million years. But with the wormhole, you can bend space sufficiently that you can go from this side to that side in almost no time at all.
Entering a wormhole would make unimaginable journeys possible. We could take trips in days or even hours that would previously take billions of years. Barreling through this tear in the fabric of space, the white hole would catapult you out in a completely different place, and maybe even time, if we can overcome one technical obstacle.
The problem is, as soon as you enter the mouth of a wormhole, it collapses. It's like trying to get inside of a soap bubble. As soon as you pierce that bubble, it pops.
So there have been some scientists who say, gee, maybe there's a way we can stop them from disappearing.
What do you do if you're at a restaurant and your table is a little bit wobbly and your drinks keep spilling? Well, you wedge something under it to make it so it doesn't shake and it's nice and stable. It's possible that something like that might exist for wormholes.
The cosmos is full of minute particles, like electrons and protons. When they interact, they produce short-lived bursts of energy. Scientists call them virtual particles, and believe these surges in power could pry open a wormhole. It sounds like science fiction, but in Los Angeles, a group of scientists is attacking the problem. Umar Mohideen is building a device he hopes could allow humans to enter a wormhole.
It's exciting to be doing this kind of research. I mean, it's very motivating, and there is the opportunity to make new discoveries. You know, that's part of the excitement of doing the research.
A component deep inside his machine has the power to revolutionize space exploration. A microscopic metal ball. Umar mounts the sphere next to a metal plate, leaving only a minute gap between them.
The separation is very small. In this case, on the order of a micron, which is about a 50th of the width of your hair. So it's awfully small separation distance.
This tiny gap traps virtual particles. And Umar thinks we can use these bursts of energy to try and force open a wormhole.
This is a frontier that you're trying to understand physical phenomena and properties of nature that are still under debate. Now, that's part of the excitement.
Umar's device only generates minute forces. But a scaled-up version could work. To pry open a wormhole, we'd have to build a huge metal sphere, millions of miles wide. Then, build another one right next to it, no further away than a single atom. Finally, we'd have to drop both spheres right into the mouth of a black hole. Then we could travel to the furthest corners of the universe.
When humanity has been able to expand the range over which we can travel and look and see and come to comprehend, that has always led to new knowledge that we've used to increase the quality of human life. Mastering wormholes would likely continue that process.
Just because we don't have the technology today, that doesn't mean we're not going to have it in the future. Think about it. It was just about 100 years ago that the Wright brothers took to the air.
Even if wormholes don't exist, even if wormholes can't exist, the mathematics, the science, the physics of figuring them out, theoretically, can lead to new discoveries and things that we can use, things that do exist, and that can benefit humanity. It is always worth investigating things like this. It's why we call it exploration.
Black holes can devour planets and stars in the blink of an eye. But now we know they have a more positive role as well. They build and control galaxies, keeping order in the cosmos. And one day, they may propel us to the distant corners of the universe. Far from fearing black holes, maybe we should learn to love them.